Hi guys, in this video we're going to be taking a look at geometric sequences in series. So previously we looked at arithmetic, before that we looked at random ones, and again I kept telling you as we were going through those we had things called arithmetic and geometric. So arithmetic was adding and subtracting, now we're getting into multiplication and division. But something to keep in mind, we are always going to be talking about geometric in terms of multiplication. So everything has to be changed to multiplication if we have a division problem. Okay? We'll go through the explorations in class. And here we go. Geometric sequences, again, talks about ratios. And a ratio is a fraction, and it's things that are multiplied together. So we're looking for the constant ratio or the common ratio, you're going to see it as. And just like the common difference was denoted as D in arithmetics, our common ratio is denoted as R. Makes life nice and easy for us. So an easy way to determine a common ratio is you're going to divide one term by the next, or by the one before it, actually. That sets up the ratio. So the pattern 1, 2, 4, 8, 16, I do 2 over 1. Then I do 4 over 2, 8 over 4. So it's always over the one previously. Okay? And that's how I would find the pattern, which is a ratio of 2. I know I'm timesing it by 2 here. And that's a pretty simple one. People say 1 to 2, 4, 8, 16. They know it's timesing by 2. Now in the next one, 27, 9, 3, 1, 1/3. Maybe you saw that it was dividing by 3, or notice you can find the ratio, 9 over 27, 3 over 9, 1 over 3, 1/3 over 1. Those are all the fractions 1/3. That's what they would all reduce to. So the common ratio in this one is 1/3. But I also noticed down here, or I mentioned down here, if you noticed that it was division, dividing by any number is the same as multiplying by its reciprocal. So dividing by 3 is the exact same as multiplying by 1/3. And that's where the ratio of 1/3 even comes from. So any division, you're always going to create it to be the multiplication of the reciprocal. And again, all terms reduced have to be the same in order to be a geometric sequence. So if they don't reduce to the same fraction, or they don't reduce to the same number, then it's not something that is geometric. So in order to determine if these are geometric or not, like I said, you're simply going to divide one term from the next. So I'll do some of these with you, just so you can see what they are, right? So in this case, I would do 12 divided by 4, gets me 3. 36 divided by 12 gets me 3. So in fact, I do clearly see, and I could keep testing all of them, but I will notice that it does reduce to a common ratio of 3. So yes, this is geometric. Now in number 2, if I was to set this up, 40 over 45, well, that's 8/9. 35 over 40, that's 7/8. So right away, I know this is not it. Okay. And again, you could probably even clearly have seen that it was just decreasing by 5 or subtracting 5 each time. Okay. And we'll go through more of those in class. You're just going to see if I divide them, do I indeed end up with the same ratio? All right, and here's our rule for geometric. Geometric rules, by the way, absolute easiest rules there is to write. Okay, because all you got to do is figure out the first term, the ratio, and they'll get multiplied together. Okay, so this is a nice, easy setup for geometric rules. All right, so for this, if we want to figure out what the rule is, again, I'm going to write that down, right? It's an equals a sub 1 times the ratio to n minus 1. So that's the generic rule. So first thing I'm going to do is find out what's happening. 15 over 5 is 3. 45 over 15 is 3. So I can see my ratio is 3. There's my a sub 1. So I can quick and easy write the rule a sub n equals 5 times 3 to the n minus 1. Okay, again, from there, I could ask you a bunch of things like find what a sub 8 is. Well, you just put that in your calculator. So a sub 8 equals 5 times 3 to the 8 minus 1 power. And that comes out to 10,935. Again, just calculate our work from there. I could do like we did in the previous one. In the arithmetic, I could ask you, well, what term does it represent? And you would solve from there as well. Okay. If you're given a random number, a random term, and the ratio, how do we find that? So again, here's our rule. Well, you just plug in everything you know, and you work your way through to solve for A1. Okay, so I know A sub 4 is 12. I know the R is 2. So A sub 4, 12 goes in the A sub n spot. A1 is what I don't know. R is 2. And then your n, remember, is that 4 there? So 4 minus 1. And again, you would just work through and solve that. So 2 to the third power in this case. Right, well, 2 to the third power is 8. And when you solve that, you find a sub 1 is 1.5 or 12 over 8. 3/2, sorry, I was blanking there, or 3/2. Okay, and again, once you have that, you put it all together to write your generic rule as a sub n equals 1.5 times 2 to the n minus 1 power. Okay, so again, you just plug in, find your A1. It's really quick, easy to use your geometric rules here. Now, what isn't so pretty sometimes is when you're given two random ones. We're still going to be solving systems, but people get a little thrown off when we solve these. So let's walk through them. So we have system 1 is going to be using a sub 2 equals 12. Again, plug in everything you know. That's your generic rule. Notice you're going to keep A1 and R as their values or their variables, because that's what you need to solve for. Okay. So this becomes 12 equals a sub 1 times R to the first power. Take the second one, do the same thing. Okay, so in arithmetic, we were solving using elimination. In geometric, we are going to solve using substitution. Okay, let's make these look the same. And what you're going to do is you're going to solve for a sub 1 in the smaller equation. So this is my smaller equation. If I get a sub 1 by itself, all you're doing is dividing. So 12 divided by R to the first. Then take that and you're going to replace, you're going to substitute in the a sub 1 in the next problem. So this is going to look like negative 768 equals 12 over R to the first times R to the fourth. Now here's why we chose the smallest one. Because when you have the smallest exponents in your denominator, you're going to end up subtracting this, because this is what it's going to look like. Negative 768, when you multiply this, you have 12 R to the fourth over R to the first, because you would multiply the numerator with the whole number, or the R in this case. And then these R's, exponent rules, we subtract them. So now we're at negative 768 equals 12 R to the third power. And that's easy enough for us to solve. Divide by 12. So that's negative 64 equals R cubed. You're going to cube root both sides to get rid of the cube. So you got to remember how to solve exponents here. and you end up finding that this is -4. So that's your R. To find A, we'll go back up to that equation, that A1 equals 12 over R1 that we found. We'll plug R in. So A1 equals 12 divided by 4 to the first power. That is 3. And then we can put everything together. A sub n equals A1 is 3 times R. Oops, I know what R is. R is -4 to the n minus 1 power. Okay, so this solving of the system is what people get tripped up on. Again, always make sure you follow this part. Get the smallest R value, take that equation to get A by itself. So that way the smallest R value ends up in your denominator. So when you substitute back in at this point here, they end up being subtracted and you have whole numbers. You're not dealing with anything that's a negative exponent. Okay. And again, we'll go through more practice with these. And then lastly, just like in the previous one, I'm just showing you to show you there is a summation rule for geometric. We're not going to use it. We're going to use Desmos. It's easy enough to plug into Desmos and get your sum. So we're going to use that. But again, just showing you to show you that there is this formula. It is the first term times 1 minus the ratio to the total number of terms, all divided by 1 minus the ratio, and you end up with the sum. But as I said, we are going to use a summation calculator to do that, just showing you to show you. So that way, if you see this in pre-calc or calc, you'll know it exists. And in those classes, you'll be finding out how and why they exist.